here's our first example. F of x equals x over, oh, no wonder you're all sitting there like, okay, here we go. That's better. So we've got f of x equals x over the cube root of x squared plus 4. So, for this, I probably would think of this as x over x squared plus 4 to the 1/3 power. In high school, I would have made that x, I would have done this. You don't have to write this down. I would have done this, x squared plus 4 to the negative 1/3 power, and then I would have done it like one of the problems on the board already. And you can do that, and you'll get the right answer. I like the quotient rule a little better now than I used to, so we won't do that. But you can do that. So if you really hate the quotient rule, you can move this up to the top and use product rule all the time. You can avoid ever using the quotient rule if you want. Now that we know the chain rule anyway. So, but let's use the quotient rule to take the derivative here. So when we take the derivative, we've got to do low, so that's x squared plus 4 to the 1/3 times the derivative of the high, which is 1, minus high, which is x, times the derivative of the low. Here's where we've got to use our chain rule. So when we're multiplying, we're taking the derivative of this part, we've got to do 1/3 x squared plus 4 to the, I got to do 1/3 minus 1, which is 1/3 minus 3 over 3, which is negative 2/3, times the derivative of the inside part, which is 2x, all over the denominator, x squared plus 4 to the 1/3 squared. So, you got a lot of stuff going on here. A whole lot. And simplifying is not very easy to do, but we can do it. So, first I just like to clean this up a little bit. This first part you can't really do anything with, x squared plus 4 to the 1/3. Minus, over here I've got 1/3 x and 2x. I'm going to put that together, so it gives me 2/3 x squared times x squared plus 4 to the negative 2/3. I'm going to put that over x squared plus 4 to the 2/3. Okay, so, I'm trying to think. I think you cannot just move this right here to the bottom of this fraction. But you could, like, make a complex fraction if you wanted to get common denominators. I think the easiest way to do this, not that it's easy at all, but the easiest way, you notice you got the x squared plus 4 here and also the x squared plus 4 here. So kind of like we were doing yesterday with some of the product rule ones, I want to try to factor that x squared plus 4 out of the numerator. So to do that, I would have x squared plus 4. And I'm going to take out the lowest exponent, which is negative 2/3. And so when I do that, it is like it's like I have divided by x squared plus 4 to the negative 2/3 on both of these. And so here, it just cancels out. Those two match. Over here, and you'll notice this always is the same thing happening. If I subtract my exponents here, 1/3 minus negative 2/3, that changes to a plus, you get 3/3, which is 1. So you'll notice if you take that lowest exponent out, it makes it where the fractional exponents go away for you in that part. So you'll have, so this one will just be x squared plus 4 to the first power. And then over here, we'll have 2/3 x squared. And that's all over x squared plus 4 to the 2/3. Okay. Questions so far? It's not done. So this has a negative exponent. I can send it to the bottom. I also could combine this x squared with this x squared. So if I do that, I'm going to have, I've got 1x squared minus 2/3 x squared, so I get 1/3 x squared plus 4 over x squared plus 4 to the 2/3 times x squared plus 4 to the 2/3. Normally I really wouldn't write that step, but just to be extra clear about what's happening here, I did. So I've moved that to the bottom. Whenever I do that, I can combine x squared plus 4 to the 2/3 and x squared plus 4 to the 2/3. So that'll give me 1/3 x squared plus 4 over x squared plus 4 to the 4/3. Hey Sebastian, how you doing?
Will you make another drilling sign?
I know what?
Will you make a drilling sign that parodies the crossing sign?
Oh, you better go into art class, buddy. That's okay. He's kind of cute. That's okay. Kind of like one to come visit sometimes. He's a little bit cute. If it was my responsibility to keep up with, I might think differently, but now this still is probably not what they're going to leave as the final answer, because it still has that 1/3 in the top, so you still have a fraction and a fraction. So there is a way we can get rid of that. I can multiply the numerator by 3 and the denominator by 3 here, because if I do that, then when I distribute that 3 in the numerator, I'll just get x squared plus 12, and then I can just leave this 3 times x squared plus 4 to the 4/3. And that's probably the way that you'll see the answer written. So, if we zoom out at all that work, I know you can't really read it whenever I do that. This is some impressive math right here. This will scare small children. My first period was asking about calculus today, and asked if we could do some calculus sometime. And I told them they were not ready for that. That maybe we might need to learn how to add integers first before we could do calculus. But I might just put this stuff up to scare them tomorrow a little bit, or not really scare them, just make them think I'm really, really, really smart. Because this is impressive looking stuff right here whenever you get done. If you get the right answer. I love these problems as long as I get the right answer. When I get the wrong answer, I really hate them because there's so much there and so many places that you could have gone wrong that it is frustrating. But I feel very accomplished when I get to the end and have the right answer on these. So, here's our next one. It's a lot like the last. 2x over x squared minus 4 to the 1/2. So to take the derivative, you've got to use that quotient rule. So f prime of x would be low times the derivative of the high, which is going to be 2, minus high times the derivative of the low. Here's where you're going to have to use that chain rule. So you'll have 1/2 x squared minus 4 to the negative 1/2. And then you got to multiply that by the derivative of x squared minus 4, which is going to be 2x, all over x squared minus 4 to the 1/2 squared. Technically, this is the derivative, and if it were free response, you technically could stop here and would not have to simplify. And if it is free response and all they've asked you for is the derivative, go ahead and stop here. That's fine. But usually you either need to simplify it so you can use it in the next step, or you have it on multiple choice where you're going to have to simplify to get your answer to match. So we need to practice doing that. So if we sort of clean this up just a little bit, I have 2 times x squared minus 4 to the 1/2 minus, let's see, here we got a 2x. So I just have to, all this sort of runs together. We got a 2x, a 1/2, and a 2x. We could put those things together. So that would be 2x squared times x squared minus 4 to the negative 1/2 all over x squared minus 4 to the first power. Oh, that's right. Okay, here. Alright, so now, just like the last one, we've got an x squared minus 4 and an x squared minus 4, so we're going to factor out the lowest exponent that we have for that. So we're going to be taking out x squared minus 4 to the negative 1/2. And so if we do that here, that means we're dividing by x squared minus 4 to the negative 1/2, and then x squared minus 4 to the negative 1/2. These cancel. Here, 1/2 minus negative 1/2 gives you 1. You see the pattern that's happening every time here. So we're going to have 2 times x squared minus 4 minus these 2 cancel, so we just got 2x squared. here. And so we can send this down to the bottom. Those two are the same, so we can combine them. This is to the first power here. Up here, we're going to distribute that 2, which will give us 2x squared minus 8 minus 2x squared. So whenever we combine that 2x and the negative 2x squared and negative 2x squared, you just get 0. So you'll just have the negative 8 in the numerator, and then you'll have x squared minus 4 to the 3 halves power here, because you'll add the 1 and the 1/2 whenever you move this down. And that we can just leave as it is. They might change it back to roots. But okay, questions here? Alright. That's another one we're going to look at. Oh, 237. Yeah, go ahead. I will keep recording those so you can watch the last couple. I'm going to let you guys try this one by yourself. end process as the last one. You got to go do low d high minus high d low right here. You've got to do the chain rule for that part. So you'll have 1/2 times x squared minus 3 to the negative 1/2. And then you have to multiply that by 2x. Yeah, we're still dropping. We're barely anybody left. They're all giving up. Yeah. Yes. Right here. Right here, what you have is a little bit different. It's a power raised to another power, so you do not add them, you multiply them. So, like, it's the difference between having, like, x squared times x to the third, which would give you x to the fifth, and then having x squared raised to the third power, and that would give you x to the sixth. So, yeah. So, right here, you've got a power raised to a power, so you're going to multiply the 1/2 into, which is where you get, I didn't write it, but you got a 1 there. And whenever you move this back down to the bottom down here, what you've got is you've got x squared minus 3 to the 1/2 times x squared minus 3 to the first power. And so that's where you add your exponents. Okay, questions? All right, I got one more that I want us to do. I think it's one more. Yep. This one is different than the last problems we did, because this one still has a quotient rule and a chain rule, but the chain rule is the outside function, whereas on the last part it was sort of like the inside. I'm seeing some looks of disgust as we look at this, but we've got to deal with it. So what we're looking at here, your outside function is this stuff squared, and then your inside function is this stuff, which is going to require a quotient rule to take the derivative of. So when we do this problem, our derivative, dy dx, or we could call it y prime if we wanted to, we're going to have 2 times 3x minus 1 over x squared plus 3 to the first power. And that's just the derivative of the outside box. That's the derivative of the something squared. So now we've got to take the derivative of the inside. But to take the derivative of the inside, you're going to have to do the quotient rule. So I'm going to put me some brackets over here and kind of try to pretend that this first part right here doesn't even exist for a little while, because we got a lot of work to do over here with the quotient rule. Justice may not make it. So we'll have x squared plus 3 times the derivative of the top, which is just 3, minus the top, which is 3x minus 1, times the derivative of the bottom, which is 2x, all over x squared plus 3 squared. So let's just leave this stuff out here alone and pretend like it's not even there for right now. So we could distribute this 3. We get 3x squared plus 9. And we could distribute this 2x. And the negative's got to go with it too. So we'll have negative 6x squared plus 2x all over x squared plus 3 squared. And so again, I'm not messing with this first part at all yet. So I could combine some stuff here. I've got negative 3x squared plus 2x plus 9. Questions so far? I'll still together here. Alright, so really now you could multiply, like this is 2 over 1, you could multiply all the numerators together and the denominators. I would probably leave it in factored form. I think you're more likely to see it that way where you don't actually multiply it out. And then you'll multiply the denominators together. Those up you can combine because they're equal to each other. So you would have over x squared plus 3 to the 3rd power. And I think you're probably just going to see it left like this. They could always multiply the numerator back together. I don't think anything will factor there where it would cancel. So they'd probably leave it like that. So this is what we end up with. Maybe not quite as horrendous as it looked at first, but still kind of difficult. Okay, questions? All right. This is your homework assignment, 27 through 34. I need to find where these are at. There might be one that I'm going to tell you is a bonus. It might not be this assignment, but I can't remember. I don't know if I even know where the... I don't even know if I have these anymore. So. I think I'm thinking of a different assignment. I think all these are ones you can do. There was one assignment that I usually give, and it had some fractions stuff in this like this, but there's one problem that I still haven't figured out how to do. So, I don't think it's this one, but I've lost my original work. So you may go ahead and get started.